Welcome back. Now, of the 10 viewers that watched my first video, I got a request to do a part 2 for PCB design. So in this tutorial, we're going to be taking a drawing of a PCB board and writing over it, and we're going to add holes. So let's get right in. The drawing, or the picture rather, that I found was this board right here. So let's say you hand sketched one, or you saw an image of one that you wanted to replicate. That's what we're going to do. So we're going to start off with a sketch. That one looked pretty square. Dimension, let's call it 5 inches. About 5 inches, whatever your stock PCB board is. We're going to extrude this 3 millimeters like we did last time. Okay, so now we need to start another drawing on the top here. We're going to go to Insert, Canvas. We're going to select our image, and we're going to select the face we want the image on, which is here. I'm going to turn this around, make it a little bit bigger, and that looks like it's going to be good right there. I'm going to hit OK. Okay, so now that we have our image here, we can start drawing. I'm not going to draw everything here. I'm going to draw a couple of these here. So we're going to start with our line tool and start drawing. Okay, we're going to add some circles here. If you hold down Control, see right now it's snapping to lines, but we're going to hold down Control. Lets us give this a little more fine control over here. Okay, we're going to add some text. Okay, that looks good. We're gonna make that a little bigger. We're gonna hit OK for the text. All right, and let's do one of these here. All right, and we're also going to finish it off by doing this rectangle feature here. I'm going to make it a little bit oversized. And we're going to hit Finish Sketch. Okay, now if you want to see what we've done, we can turn off all canvases, or if you have more than one, you can turn off individual canvases. And we're left with what we've drawn. These are a little close to each other. If we made a mistake and we want to edit the sketch, we can edit the sketch. Let's move that over a little bit. And this looks good. Okay, now we're going to save our model here. I'm going to call it Tutorial PCB 2.0. All right, now we're going to move into the CAM workspace. And nope, I skipped a step. we want to actually cut this into our board. So we're going to go to Extrude, select our profiles that we want to bring down. Distance, we're going to go -1 millimeter, and we're going to hit OK. we did want to cut these holes out. So I'm going to turn my sketch back on, go back to extrude, select the holes, and in this case we can either draw it further than we want to, or we can change distance to through all. And now we have some holes here that we're going to drill. You'll notice, yep, I forgot the outline. I'm going to go to Edit Feature. And actually, it looks like I did not forget it. Okay, now we're going to go to our CAM workspace. And we are going to set up our machine. I've done this previously, so I'm not going to speak too much on that. We're going to change our stock to 0 offset from the model. Hit OK. Turn off our machine so we can see better. So the first thing we're going to do is we're going to do a few roughing passes. So we're going to go to Pocket Clearing and select our tool. We're going to use a tapered mill. Let's see what options we have here. Ideally, you would have a very thin tip. We're going to go with this one. Change our coolant to off. Spindle speed 10,000. Cutting feed rate, we're going to slow that down to 400. Now for geometry, we're going to change that to selection, and we're going to select the bounds within which it's going to cut. So this feature right here, everything inside of here will be included in the geometry. We're going to leave our heights alone. Now under passes, we're going to change our maximum roughing step down to 0.5. I like to reduce the stock to leave to 0.2, and we're going to hit OK. So here we see what our roughing pass looks like. If we zoom in, we can see that it did kind of clear out the holes somewhat, and the text, I guess, was too thin for our bit here. If we wanted to, we could add a new toolpath, which we'll do that at the end. So now we want to take care of these holes here. So we're actually, before that, we want to do a finishing pass. So we're going to go to 3D, and we could do parallel. I like to do start off with the contour. This will take care of the vertical edges. We're going to leave the same tool here. Geometry. Again, we're going to select everything inside of this box. And for passes, maximum step down, I like 0.5. And we're going to hit OK. This should take care of any remaining stock. Okay, so now we've taken care of the axial stock. Now we want to make a nice flat finish on the bottom. So we're going to go back to our 3D tools, and we're going to do a finishing operation to make things flat. Use the same tools, the same settings. Geometry, again, we're going to do the selection. It might give us an error here. We don't really need to mess with step down since we only have 0.2 millimeters to shave off. I'm going to hit OK. It's thinking. Now, since this is a very thin bit, it's going to take a while to compile this. If this step is not important to you, if you don't want it to be a nice smooth finish, we can actually skip this. It's taking a while because it's got to calculate all the tool paths. Now see, here we had an error because we selected everything within here, so it's assuming that we want 0.2 millimeters to be taken off the general surface here. So if we go to simulate to see what it's doing, I'm going to speed it up. You can kind of see this is going to take a while, but you can see what it's doing. It's just shaving off that rest of the axial surface here. Meanwhile, we can check. Oh, machine time 17.5 hours. Okay. You see, that's probably what's taking the majority of our time here. So we're going to stop, exit simulation. We're going to reselect our boundary. So under geometry, we're going to start saying between here, inside of here. Looks like actually the roughing pass did carve this out. We're going to leave that. And everything within here. And we're going to hit OK. So it's going to recalculate the toolpath. Hopefully it's not going to do this big area here. So success. If we want to just check the machine time, total time is 1.5 hours. That's a bit more manageable. You'll also notice that it did actually clear these holes out for us. If it hadn't, we would have done a drill operation. But now we've got our PCB board finished out. So again, if we wanted to, let's say we wanted to do a better cutout of text, or if we had other text that we wanted to put on and just engrave it, we're going to do a little bit of an advanced thing here. We're going to do a tool change. So we're going to go back to, we're going to go to 2D, engrave. We are going to select an engraving bit. So let's say, I think this is one we've used before. Turn off our coolant. Change our spindle speed and feed rate. Now geometry, we're going to select our text. And we're going to hit OK. Let's just double check heights. Now, if this hadn't already been machined, we would select multiple depths. We'd step it down 0.5 millimeter at a time, but we're just going to leave that. This should clean up the edge if it needs it. We're going to select OK. So now we have different tool paths with different tools. You don't have to export each one individually. You can export them in groups, so that's what we're going to do. So I'm going to select one. I'm going to hold down Shift, select all three, or you can hold down Control and click on each one. And we are going to post-process. We're going to create a folder called, new folder, tutorial PCB 2. I'm going to select this folder, and I'm actually going to put it up on screen here. So we're going to call this tapered mill. So we know that this toolpath is going to be used with the tapered mill. We're going to make sure our safe retract is set to clearance height, and we're going to hit post. So you can see here now we've got one machine path that will do all three of these, and we're going to need to change the tool on the machine when we do this engraving. So we're going to export the engraving separately as a post process, underscore engraving bit post. So now we have two tool paths that each do something different. So you can load the tapered mill code into your UGS or Candle, whatever you're using. When it's complete, you change the bit, you re-zero the Z only. That way it'll use the coordinates from everything else and get back to work. So there you go. Those are some more advanced PCB things. And thanks for watching.